is the relearning for the first standard on the thermal energy test. Some key definitions you need to fill out on your relearning paper. First is temperature. It's how hot or cold something is. Heat is energy in transit. And thermal equilibrium is when two objects reach the same temperature. In your notes, you need to write down that heat moves from hot to cold or high temperature to low temperature. And also you need to know that objects do not contain heat, is not within them. It is in the movement of thermal energy from hot to cold. Remember that temperature is just an average. So if two things have the same temperature, they have the same energy per gram. So that's number 3. Two things have the same temperature, they have the same energy per gram. If one of those two things is bigger, it has more total energy. In thermal equilibrium, two objects in contact with one another will reach the same temperature. The final temperature will be closer to the object that has more mass, all right, that has more mass. If a small beaker, so this is not in your notes, you don't write this down. If a small beaker of cold water is placed in a large amount of hot water, the final temperature will be closer to the hot water. Why? Because the larger amount has more total energy or internal energy, so it has more to share. Proportions, we need to know that the temperature change and volume are inversely proportional if you're adding the same amount of heat. So if two equal amounts of water are put in thermal contact, and when two equal amounts of water are put in thermal contact, their final temperatures will be an average of their original temperatures. We cannot predict with our math abilities. You do not have the equations to predict final temperature if the amounts are not equal. So they have to be equal. So that was a question that got people messed up on the test. Let's move on to the practice problem. Please reference your notes as we go through these. One thing I would like to add to your notes is up by temperature. Please add proportional to the average kinetic energy of an object's molecules. So it's directly proportional. So as one increases, the other increases by the same factor. So let's skip down here. At this point, you should have filled out all of your notes. Let's look at the problems. So the problems, a cup of iced tea is brought into a warm classroom. Which way does heat flow? Well, if we look back in our notes, it says that heat moves from hot to cold. So heat is moving from the air into the iced tea. It does not flow the other way. What happens to the temperature of the iced tea? It increases. What happens to the total energy of the classroom's air? Well, it actually decreases. Because that heat has flowed from the air into the tea, the total energy of the classroom's air has decreased. Now, has it decreased a lot? Probably not, because iced tea is probably a very small amount, but it has decreased. Moving on to number 11. Once the cup of tea and the classroom reach thermal equilibrium, which has more total energy? Well, the total energy is dependent on the mass or the size. And so in this case, that would be the air of the classroom. Number 12, heat is added to 1 liter of water, increasing the temperature by 10 degrees Celsius. If that same quantity of heat is added to 5 liters of water, how much will the temperature increase? Take a minute and think about that while I pause the video. All right, so the first thing I'm going to do is I'm going to draw a quick sketch because otherwise my brain has a hard time picturing what's going on. So this one increased by 10 degrees. We don't know how much this one increased. So you got to think inversely proportional. So what do we do to 1 to get 5? Well, you multiplied it by 5. So we need to take 10 and divide it by 5. And 10 divided by 5, we all know, is 2 degrees Celsius. I'm going to circle or put a box around my answer. Number 13, heat is added to 3 liters of water, increasing the temperature by 9 degrees Celsius. If that same quantity of heat is added to 1 liter of water, how much will the temperature increase? Well, 3 liters times, divided by 3 will equal 1 liter. So now I got to go to 9 degrees, and I'm going to do the opposite function, which is multiplication. So multiplied by 3 equals 27 degrees Celsius. So it's going to increase a lot more, but you're heating up a lot less water. So again, the more we can imagine this, the better off we'll be. Number 14, a beaker of water with a temperature of 40 degrees is placed in a beaker containing an equal amount of water, 100 degrees Celsius. So these two are just going to reach thermal equilibrium, and in my notes I see that I can just find the average. So 140 divided by 2, because I have two numbers, two temperatures, two amounts of water. So their final temperature is 70. Also, we can imagine it's going to meet in the middle, right? It's not going to get hotter. The cold water is going to cool the hot water down. The hot water is going to warm the cold water up. They're going to meet in the middle. Try number 15. A beaker of water with a temperature of 15 degrees Celsius placed in another beaker containing water with a temperature of 25 degrees Celsius. Again, same thing. They're equal, so we can predict that final temperature. It gives us 40 divided by 2 gives us a final temperature of 20 degrees Celsius. So everyone, you need to go ahead, you need to do the practice problems, use your notes. Please don't just stare at them. I know we have a tendency, you want to get it done. You need to go back, look at your notes, look at the other problems. That will be more efficient. I hope this was helpful. Please let me know if you need additional help. I will be available for ASLS many days over the